Welcome to iiOCS.com Food Tech Club. Today's topic is food preservation by freeze drying. Conventionally, food preservation is done by the application of heat, as we all know. The heat used to dry foods by boiling removes water and therefore preserves the food by a reduction in water activity. However, the heat also causes a loss of sensory characteristics and nutritional qualities. In freeze drying, a similar preservative effect is achieved by reduction in water activity without heating the food. As a result, nutritional qualities and sensory characteristics are better retained in freeze drying. Let us look at the definition of freeze drying. So, freeze drying can be defined as the process of preserving food products by freezing them and then evaporating the water in the form of ice directly into vapor by sublimation. So, this sublimation process we'll understand more about it later. So, what do we basically do in freeze drying? So, we freeze the food and then directly convert the water in the form of ice to water vapor, skipping the middle phase, that is liquid phase. Okay. Freeze drying produces one of the highest quality food products obtainable through any drying method and allows for rapid and near complete rehydration. Freeze drying a product consists of three stages. First one, the product is frozen so that the water contained in it becomes ice. So once the food is frozen, then the ice in the product is made to vaporize without passing through the liquid phase. This process is known as sublimation. The vapor is collected by use of condensers and once removed from the freeze drying chamber becomes ice again. That means whatever vapor we are removing from the food product, we are condensing it back into ice in order to make the removal of the moisture easy. Finally, the secondary desiccation, that is secondary drying, involves eliminating the water that was not converted into ice during the first stage. So whatever bound water which is not frozen in the first stage, that will be removed in the final drying. Let us see the principle behind freeze drying. Freeze drying, also called as sublimation drying or lyophilization, is the drying of a product in frozen state. The ice evaporates without passing through the liquid state, that is, it sublimes. So what is basically sublimation? The conversion of solid phase of water directly into vapor phase, skipping the liquid phase. Conditions of sublimation of pure ice therefore exists below the triple point. So in the graph you can see the triple point is the point at which you have all three phases, that is liquid phase, gas phase and the solid phase in equilibrium. Okay, so as it moves away from triple point, you can see you have separate curves for different phases, but in the triple point, so all the three phases are in equal amount, are in equilibrium. So the conditions of sublimation of pure ice therefore exist below the triple point. So we can get this sublimation process below the triple point, that is around 0.01 degrees Celsius and 610.8 Pascal pressure, at which all three states of matter can exist. Freeze drying is always done under vacuum. So this is the key to sublimate any liquid. Okay, so the pressure is reduced in order to decrease the temperature of boiling point of the liquid. The sublimation temperature is determined by the value of the reduced pressure. It should be noted that sublimation process is only possible below the so-called eutectic point. So eutectic point is similar to the triple point. So here we have the water in two forms, the liquid and the solid phase. Okay, so below this point we can achieve sublimation. If it reaches eutectic point, it is difficult to, we have the if it reaches eutectic point, that means we have liquid phase. So we don't want to have liquid phase, just solid phase is enough. Okay, so below eutectic point, if we reduce the pressure and increase the temperature, so then we'll get the sublimation process. Yeah. So coming to the history of freeze drying, the freeze drying process was developed as a commercial technique that enabled blood plasma and penicillin to be rendered chemically stable and viable without refrigeration during World War II, when the blood plasma and penicillin were needed to treat the wounded in the field. So during World War II, in order to supply enough amount of blood plasma and penicillin without any refrigeration, so there was no cold chain transportation that time, right? That's why without any refrigeration, in order to provide the blood plasma and penicillin to the wounded ones, this freeze drying was first found. So in food, it came at around 1950s to 1960s, and it began to be viewed as a multi-purpose tool for both pharmaceuticals as well as food processing. So at present, nowadays, we have more than 200 products being food freeze dried. Let us see the construction of equipment of the freeze dryer. Freeze dryers consist of a vacuum chamber which contains trays to hold the food during drying and heaters to supply latent heat of sublimation. So the basic chamber of freeze dryer is vacuum chamber. So in that, what do you have? You have the trays or the plates which hold the food, and they are connected to the heaters. So you have to apply the initial amount of heat in order to start the sublimation, right? For that you have heaters. After that, refrigeration coils are used to condense the vapors directly to ice. So this is called reverse sublimation. So whatever vapor we have sublimated, that will be sucked out, and in a separate chamber, the refrigeration coils, they will condense back all these vapors coming out, and then it will be removed. These condensed vapors in the ice form, they are removed later. So these refrigeration coils are fitted with automatic defrosting devices to keep the maximum area of coils free of ice for vapor condensation. So once it is condensed, so the defrosters, will remove the condensed ice. Okay, the condensed frost or the ice. This is in order to make sure that the condenser is not covered with this frost and the efficiency is not decreased. Okay, this is necessary because the major part of the energy input is used in refrigeration for the condenser. So the condenser needs a lot of energy in order to condense all these vapors. So if the frost covers the condensers, then we need more energy to condense the incoming vapors, right? That's why frequently the condensers are defrosted. The economics of freeze drying are therefore determined by the efficiency of the condenser. So after that we'll see the vacuum pumps. So these remove the non-condensable vapors. The vapors which are not condensed in the condenser, they are removed by vacuum pumps. Different types of dryers are characterized by the method used to supply heat to the surface of the food. So we have two methods, batch method and continuous method. In batch drying, the product is sealed into the drying chamber. The heater temperature is maintained little high for initial drying and then gradually reduced over a drying period of 6 to 8 hours. In batch dryers, the drying is done batch wise. It is sealed inside, it is not moved. So drying is done batch wise. In continuous freeze drying, trays of food enter and leave the dryer through vacuum locks. A stack of trays excuse me. A stack of trays interspersed by heater plates is moved on guide rails through heating zones in a long vacuum chamber. So whatever food is put inside, that will be freeze dried and then moved to the next zone. Okay, so this is the continuous process. So here is the picture of batch freeze drying. Okay, you can see the drying chamber. Okay, in that you can see the number of plates here. Okay, so once you pre-freeze and the pre-frozen food is feeded into this, the food is completely freeze dried and then it is removed. Okay, this is batch drying. So in the next section you can see the condenser, and in the last section you can see the vacuum pump which removes the non-condensable vapors. Yeah, let us see about the stages of freeze drying. So freeze drying involves 3 major stages. Okay, in the first stage, what do? We freeze the food. Okay, the food is frozen to minus 18 degrees Celsius. So the core of the food should be reaching minus 18 degrees Celsius. Okay, the next step is sublimation. This sublimation step is also called as the primary drying, and the last step is secondary drying. Let us see more about these steps. Yeah, first step is pre-freezing. The first stage of freeze drying is to freeze the food in conventional freezing equipment. Rate of freezing affects the quality of product as well as rate of drying. So rate of freezing is how fast we freeze. So you must have studied the different types of freezing in my previous lecture, right? So we have 2 types, that is rapid or fast freezing, then slow freezing. In fast freezing, what happens? The crystal formed are small. Okay, we are giving less time for the water to form crystals. That's why it will form very small crystals. Whereas in slow freezing, it has a lot of time to form bigger the ice crystals, right? That's why bigger ice crystals are formed, but these bigger ice crystals, larger ice crystals, they might damage the cells of the food. That's why rapid freezing is preferable in freeze drying. Okay, rapid freezing produce small ice crystal which do little damage to the structure of the product. but they leave behind very small pores and capillaries which offer a great resistance to the passage of the vapor. So what happens in rapid freezing? You have very small crystals. So when the crystal is vaporized, so you are left with very small pores, right? So this will resist the movement of the vapor from the next layer which is getting sublimated, right? So in slow freezing, it produces large crystals and they make rapid drying possible. But the disadvantage is of large crystals that damages the cells. So this produces separation and denaturation of protein, as well as when rehydrated, the texture will not be as good as the rapid frozen products. Yeah. So after pre-freezing, we have the next step called sublimation or primary drying. If the water vapor pressure of a food is held below 610.8 pascals and the water is frozen, when the food is heated, the solid ice sublimes directly to vapor without melting. So we are reducing the pressure and then we are heating the food. Okay, when the pressure is reduced, the heating temperature is also reduced. That's why the ice sublimes directly to vapor without melting. Water vapor is continuously removed from food by keeping the pressure in the freeze dryer cabinet below vapor pressure at the surface of the ice, removing vapor with a vacuum pump and condensing it on refrigeration coils. So I have explained this before also. So we are keeping the pressure below the vapor pressure of water. Okay, so the temperature for boiling of water is reduced now. So in this level, the vapor is sublimated and which is collected by vacuum pump, and then it is condensed on refrigeration coils. As drying proceeds, sublimation front moves into food. So what is the sublimation front? The layer which is undergoing sublimation is called sublimation front. Okay, usually the outermost layer undergoes sublimation first, then the sublimation front goes on moving to the inner layers. Okay, after vapor travels out of the food through channels formed by the sublimated ice and the vapor is removed. Yeah. After primary drying, it is the secondary drying. The secondary drying phase aims to remove unfrozen or frozen water molecules, since the ice was removed in the primary drying phase. So as explained before, in the secondary drying phase, what do? We try to remove the water molecules which was not frozen before. Okay, the bound water molecules which are held in between the food molecules, so that are removed by the application of heat. In this phase, the temperature is slightly raised than in the primary drying phase and can even be above 0 degrees Celsius to break any physico-chemical interactions that have formed between the water molecules and frozen material. So as I told before, if there is any physico-chemical interaction, that is the bound water molecules, so if they are there, the temperature, little rise in temperature will allow the water molecules to break the bonds and then to sublimate. Usually the pressure is also lowered in this stage to encourage desorption. Yeah. Let us see about different types of freeze dryers used. There are 4 types. First one is contact or conduction freeze dryers. then accelerated freeze dryers, radiation freeze dryers, microwave and dielectric freeze dryers. Yeah. First one is contact or conduction freeze dryers. By looking at the name itself, you can tell that the food is in contact with the heating material. Okay, that is why it is also called as conduction freeze dryers. Food is placed onto ribbed trays with rest on heater plates. This type of equipment dries more slowly than other designs because heat transfer by conduction to only one side of the food is happening. So the heat transfer happens to the layer which is in contact with the food. That is why it is called as conduction, right? So the above layer which is not in contact with the heating source, that will undergo drying very slowly. Okay, there is uneven contact between the frozen food and the heated surface, which further reduces the rate of heat transfer. There is also a pressure drop through the food, which results in differences between the drying rates of the top and bottom layers. The fine particles of product may be carried over in the vapor and lost. However, contact freezers have higher capacity than other types. The previous picture you had seen here, this is a type of contact freeze dryer. Yeah. Next is accelerated freeze dryers. In this equipment, food is held between two layers of expanded metal mesh, as you can see in the picture, and subjected to a slight pressure on both sides. So this can be done for solid foods. Heating is by conduction, but heat is transferred more rapidly into food by the mesh than by solid plates, and vapor escapes more easily from the surface of the food. Both mechanisms cause a reduction in drying times compared with contact methods. Yeah. Next is radiation freeze dryers. Infrared radiation from radiant heaters is used to heat shallow layers of food on flat trays. So on flat trays, the radiation is moved into the shallow layers of food. There is no pressure drop through the food, and constant drying conditions are therefore created. There is little risk of product carryover. Close contact between the food and heaters is not necessary, and flat trays are used, which are cheaper and easier to clean. Yeah. The last type is microwave and dielectric freeze dryers. So in microwave heating, so what do? Microwaves are used in order to heat the water molecules of the food. So microwave heating is the result of the interaction between microwave fields and dielectric properties of material. In this heating, the required power of sublimation is carried by electromagnetic fields to the frozen region, independent of the thermal characteristic of dried region, and then it is dissipated in frozen region and converted to heat. Compared to conventional freeze drying process, penetrating electromagnetic fields and transferring the needed energy independent of thermal characteristics of dried region are the main factors in accelerating dehydrating process in microwave freeze drying process. So here in this process you don't have to worry about the conductivity of a particular food. So whether the food is a very good conductor of heat or not, you don't have to worry about that, because the electromagnetic fields will be penetrating inside and then they will be transferring the heat energy. Okay, there is no need for the food itself to transfer the heat. Yeah, so that's all about the different types of freeze dryers. Let us see the effect of freeze drying on foods. The texture of freeze dried foods is well maintained. There is little shrinkage and no case hardening, unlike the conventional drying methods. Okay. The open porous structure allows rapid and full rehydration, but it is fragile and requires protection from mechanical damage. So all kind of freeze-dried products are hygroscopic in nature, that is, they absorb water very fast. Okay, their rehydration capacity is very fast. On the other hand, it is very fragile also. So in further slides you will see the freeze-dried ice creams and all. So if you don't handle it properly, it will break fast. And also, as the rehydration capacity is very fast, if a little amount of moisture enters the packaging material, then the quality of the freeze dried food will be decreased. So it will absorb the moisture very fast. Okay, so the packaging material and also the handling of freeze dried products is little difficult. There are only minor changes to proteins, starches or other carbohydrates in freeze dried products. However, the open porous structure of the food may allow oxygen to enter and cause oxidative deterioration of lipids. Food is therefore packed in an inert gas. Changes in thiamine and ascorbic acid content during freeze drying are moderate, and there are negligible losses of other vitamins. Excuse me. Let us see some advantages of freeze drying. So in freeze drying, there is minimum damage to the product and loss of activity in the food product, and also loss of heat labile materials is less in freeze dried products. Creation of porous and then friable structure gives a better quality of freeze dried product. So the rehydration capacity is also more. Speed and completeness of rehydration is more. The ability to sterile filter liquids just before dispensing is easy. So if we look at the disadvantages, so high capital cost of equipment, then it consumes a lot of energy even for creating vacuum and for condensation, and also for vacuum suction. So for everything you need a lot of energy, and also as this is a slow process, so more than 12 hours of drying is required. So it is a time consuming process as well as energy consuming. Energy and cost is high for this. Possible damage to products due to change in pH and tonicity when solutes concentrate as pure water freezes into ice. Yeah. So let us see some applications of freeze drying in different areas of food industries. Because of the light weight of the freeze dried products per volume of reconstituted food, freeze dried products are popular and convenient for hikers as military rations or astronaut meals. A greater amount of dried food can be carried compared to the same weight of wet food. In replacement of wet food, freeze-dried food can easily be rehydrated with water if desired, and shelf life of the dried product is longer than the fresh or wet product, making it ideal for long trips taken by hikers, military personnel or astronauts. So the main thing here is the rehydration capacity is very good. The final product, when you rehydrate, it gives the feel of the fresh product itself, and also it is very light to carry. The development of freeze drying increased meal and snack variety to include items like shrimp cocktail, chicken and vegetables, butterscotch pudding and apple sauce. So variety of foods can be freeze dried, and they can be provided for military rations as well as astronauts. Let us see the application of freeze drying in coffee industry. Coffee contains flavor and aroma qualities that are created due to the Maillard reaction during roasting, and can be preserved with freeze drying. Compared to other drying methods like room temperature drying, hot drying and solar drying, Robusta coffee beans that were freeze dried contain higher amounts of essential amino acids like leucine, lysine and phenylalanine. So the protein retention is also high. Also, few non-essential amino acids that significantly contributed to taste were preserved in freeze-dried coffee. So next is application of freeze drying in drying of fruits. With conventional dehydration, berries can degrade in quality as their structure is very delicate and contain high levels of moisture. Strawberries were found to have the highest quality when freeze dried, retaining color, flavor and ability to be rehydrated. So the dried fruits, when you rehydrate, will give you the fresh feeling. It will have maximum retention of color, flavor and the texture of the dried food. Okay, let us see some pictures of dried foods. So this is the freeze dried bacon, and then you can hear, it is named wrongly, it is the freeze dried coffee. So you can see the freeze dried coffee powder. So this is made into agglomerates. So you even have the freeze dried coffee powders. Okay, so this is the freeze dried coffee agglomerates. Next one is freeze dried apricots, melons and meatball soups. So this one is freeze dried ice cream. So this is what we spoke about before, freeze dried strawberry. Okay, so this is not after rehydrating, this is before rehydrating. Last one is freeze dried spaghetti pasta. Yeah, that's all for today. Continue your studies with iiocs.com Food Tech Club. For any queries, you can contact the number on the screen here.